First type is a combination reaction. In this one, two or more substances come together to form a larger substance. Okay, so that makes sense. We could do the opposite of that, and that's a decomposition reaction. Oops. So a substance breaks apart. These types of reactions are not easy to predict products, so I'm giving you those, but you should be able to see that this one is combination and this one is decomposition. That's pretty easy. Something you need to know, decomposition often requires heat. And I've indicated heat right here with this triangle. The triangle over the arrow means that heat is applied to make the reaction go. This is done for a reaction that doesn't occur very fast without it, but by adding the heat, the reaction occurs at a reasonable rate. This one also required heat, but it's actually much more common in decomposition reactions. Okay. This next one involves something replacing something. So let's look at the products. Can you tell what is replacing what? The iron is replacing the copper in the compound. Since it's just one element replacing the other, we'll call this single replacement. It can also be called single displacement. Not a big deal. I say both. Usually I say replacement. But anyway, so that is a single replacement. And something you need to know about those is that more active element forms the compound. So in this case, the more active element is the iron. And we'll get into later how you know which one is more active and all of that. But for now, that'll do. The more active one ends up in the compound. It's kind of like it wins the battle. Okay, last type. You might have noticed up here we have an element and an ionic compound. On these we have there's no element by itself. We have two compounds. Usually they're both ionic, but sometimes we have an acid because when an acid is dissolved in water, it acts like it's ionic. So anyway, kind of an ionic compound. What happens is they switch ions. So I'm going to just start with sodium. Sodium is at the front of this one, so that means it's positive. It's going to go with the back end of this one. Later we really will work on predicting these types of products. These are pretty easy to predict. And then the front part of this one goes with the back part of that one. Okay, and this is just a funny way of writing H2O, water. We do that sometimes, so it's not just me making it up. Okay, so do you see how this might be called double replacement? Because both of them switch, both ions switch. In order for this to happen, one product must be a solid, a gas, or molecular. These two products are not solids or gases, so we must have a molecular product, and we do. Water is a molecular product. It's Remember, molecular is another word for saying covalent compound. So nonmetals only, there's our covalent compound. That allows this reaction to occur.